Okay? So, cannot add, put here. So what if I had 2x squared plus 3x squared? Is it Karina? You said 5x squared? Are you sure? Stick to your guns, girls. Stick to your guns! 5x squared is correct. Because what? I added the coefficients and kept the baggage. Not touching that square, I'm just carrying along like baggage. That's it. So the process, let's do some subtraction in a second, but that's just adding. The process is add the coefficients. I'm going to put the process down here. Process says add or subtract. Coefficients, cuffs, and take the baggage with it. Take baggage. Bags. Take bags. Take the bags with it. That's the variables. Those are the variables I'm talking about. Or the variable, just one. Bags here is variable. Okay? Subtraction, different story. Not different story, same process. Just done a little differently. So if I have 2x minus 3x. Victor, I haven't heard from you. A little quiet over there. Taking diligent notes. I like it. Help me with this one.
That would be minus 1x.
Minus 1x is correct. Or you could say minus x. Put the invisible man back and just keep the sign in front. Excellent. What about if I had 3x squared minus 5x squared? What's your name again?
Casey.
Casey? What do you think? Nice vest. I like it.
Would that be 1x squared?
Okay, remember what the process is. Add or subtract coughs, or coefficients, and take the bags. What's 3 minus 5?
-2.
-2. Thank you, Megan. And take the bags. X squared. That's it. Let's try. What if I have 3 numbers? Uh-oh. 3x squared minus 2x squared plus x squared. Uh-oh. Price of poker just went up. Terminology. That means the ante just got bigger.
We still do the same thing, work left, correct?
You could. Left to right is a fair bet.
I would say that would,
Victor, you want to help me out again? Or is it, oh, it's on. Yes.
I would say 1x squared.
You would say?
Yeah.
You're not sure, huh?
I'm gonna go with it.
Let's go left to right. Ken said we can go left to right on this one. He's right. We can do that. It's a fair bet. You can also do 2 different ways, but let's just go from here. 3 minus 2 is 1x squared. Bring down the other 1x squared. Process says add or subtract the coefficients and takes its bags. 1 plus 1 is 2x squared. I'm finito.
What's the other way you do it?
The other way, I'll do 4 terms because it works better with the longer ones. You're going to see this too. They just get bigger and bigger. Let's say I have 3y squared plus 2y squared minus y squared minus 5y squared. I got 4 terms. 1 coefficient, 4 terms. 1, 2, 3, 4. 4 terms. Okay? So I could just take all my positives, get them all together. So all my positives are here. So 3, actually I'm going left to right anyway, aren't I? So I should separate this, but I'll do one more. So I take my 3 and 2, make that 5y squared, get them out of the way, and then take these guys and say minus 1 minus 5 is minus 6y squared. And then get rid of those, and now I have this. So now what's this going to be?
1 y squared.
Minus y squared.
Oh, yeah.
The negative takes the bigger, is the bigger sign, so it takes the negative sign with it. And I take the baggage. So you can say either minus y squared like that, or you can say minus y squared like this. Whoops. Okay? So that's collecting like terms. That's if we add or subtract. Multiplication and division, totally different story. Totally different story. Different story. Now we have to apply. When we multiply and divide, we have to go to the exponent rules. We have to refer to exponent rules. What are the exponent rules you're supposed to be asking me? Brianna, you fall asleep on me?
No.
What are my exponent rules? Talk to me. If you don't know, you just say you don't know. It's okay.
You multiply the base and
Ah, she's on it. Good girl. Good job. I like it. So here's exponent rule number 1. X to the n times x to the m is equal to x to the n plus m. And that's called the product rule. They have names to them, by the way. This is called the product rule. I hear it now. The moaning, the groaning. This is where it starts. Fight it. It's not bad. You can do this. Anybody can do this. Anybody. Except my dog. I've been trying to work on my dog, but he has no thumbs, so it doesn't come along. Can't get him to write the pencil. Can't get him to take notes. My dog's name is Merlin, by the way. Merlin.
Can you go back to how you get 6yx squared?
Say what, Victor?
Can you go back to how you get minus 6yx?
So, okay, so I'm subtracting 5 minus 6.
Yeah, I want to know how you get 6.
How did I get 6?
Yeah.
Well, here's minus 1, and here's minus 5. Minus 1 minus 5 is minus 6. So I took my negatives, added them together, took my positives, added them together, and that's what took me to this next step. So it's a 2-step process. Let me sum. Go ahead. Victor, what's the matter? Talk to me.
Minus and minus is plus.
Only when you multiply. If it's minus minus 1 degree Celsius and it just got colder. You with me now?
Gotcha.
When you're moving addition subtraction to minus, you have to consider the direction it's going into. But when you multiply them, then you've got that rule, negative times a negative is positive. So yeah, we got a bunch of rules we got in our head, we're trying to organize them. I can sympathize with that. Alright, you got donuts next time? Oh, is that me? Because I got donuts. I left mine on. Oh, this is my timer. My time is over.
You ain't getting away from bringing out donuts.
I brought candy. I'll spread out the candy I have for a quiz. Alright, let me get into one more thing. Let me get into some more of these rules. So I'm gonna throw these rules at you and sort of all one so you can at least try the homework for tonight. So here's the product rule. These are the rules. I'm going to state them. There's like 5 of them. So the first one's a product rule. The second one is the power rule. X to the n raised to the m power is x to the n times m. Now these are just, think of these as recipes. Think of these as recipes, and I'm giving you recipes to work on for next time. So if you see an n raised to another power, so power to a power, that's what this one's called. Power to a power. Rule or property. I like rules. Means you're going to multiply the exponents. As opposed to before, we're adding the exponents. So 2 different things that tend to be confused, but looking at it from this standpoint, you see parentheses with one exponent raised to another exponent. That means you multiply. Okay? That's called a power. And then we have this doggone thing. We've got x to the minus 1, my negative exponent rule. That's the same as 1 all over x to the positive 1. It's called the negative exponent rule.
minus 1 equals 1 over x.
To the positive 1. It's called the negative exponent rule.
I've got a quick question.
Yeah.
For the second one, let's say we have x raised to the fourth raised to the fifth. So we multiply and the base stays the same?
Well, you notice the base hasn't changed. The base has to be the same in order for all this to work.
Okay.
So, Brianna, you asked about the first one?
The
Or-
second one.
Second one. So if you have x to the fourth, all raised to the fifth power, that's what they look like. Now, it could be, the base could be anything. Here it's just x. So what if I just change this to 2? Same process, except I'm going to get the same base as a result. And this would be 4 times 5, which is 20. So 2 to the 20th power. Okay? So don't worry about the x's so much, because it could be anything. It could be anything you want. And then the other one, this one, if I have, let's say, let's do it this way. Let's say 3 to the second power times 3 to the fourth power. Here, looks like this one. Right? It's not a negative, it's positive. So what are we going to do with the exponents? I'm going to add the exponents, so I keep the same base, 3 to the sixth power. And then you can let your calculator do the rest, or you can just go 3 times 3 times 3 times 3 times 3 times 3, 2, 3, 4, 5, 6. And then you can multiply all these together. Get something big, 243 or something like that. Anyway, so that's these two rules. Now, this rule here, x to the minus 1, let's say I have 3 to the minus 1. What's the rule say? It's going to be 1 over the base with the positive 1, which is the same as 1/3.
So it's like the 1 is applied.
One invisible man is always there. If there's nothing there, 1 is always there. Okay? One more. I'm going to throw one more here. And this is an easy one. X to the 0 power. No, it's not 0. It's 1. Always 1. Totally confusing. Don't ask me to prove it right now. So if I have 3 to the 0 power, this is not 0. It is 1. Nor is it 3. It's always 1. If I have 5,000 raised to the 0 power, with parentheses, notice, always 1. Always, always.
So x to the 0 power, the answer is 1. You said it.
Always. Whatever x is, x to the 0 power is always equal.
So anything to the 0 power is equal to 1.
Anything. So if you want to do it that way, you could say this. Anything raised to the 0 power is always 1. We mathematicians call that x, by the way. We call that x. Anything. Anything goes means x. You have the power of x. Okay? All right. So take a stab at that homework.
I thought you said there was 5 rows.
There is. Want me to throw the fifth at you?
Minus 12.
Might as well.
No.
The book kind of changes this one around a little bit.
They're all the same dose.
Okay, you want it? You got it, my man. It's actually a version of this one. It's the inverse of this. Actually, it's not. It's here it is. X all over y, all raised to the n power. This means that x to the n all over y to the n.
Oh, that I answered.
These are all n's. So if I have 2/3 all raised to the 3rd power, this is going to be 2 cubed all over 3 cubed. You should know your cubes, right? What's 2 cubed? 12?
8.
8. 2 cubed is 8. Thank you. Thanks for playing. What's 3 cubed? 27. So 8 over 27.